Hello everyone, today we're going to be doing a demonstration. We're going to be using balloons. I got a bunch of different balloons lined up here. We're going to be using them to illustrate the valence shell electron pair repulsion theory. So that's a mouthful. It's the VSEPR theory, and this model can be used to predict the shapes of many molecules and polyatomic ions. So the VSEPR model, however, like any model, is a limited representation of reality, and it doesn't provide any information about bond lengths or the presence of multiple bonds. So diving deeper into the VSEPR model, we can use it to predict the structure of nearly any molecule or polyatomic ion in which the central atom is a nonmetal, as well as the structures of many molecules and polyatomic ions with a central metal atom. So the basic premise of the VSEPR theory is that electron pairs located in bonds and lone pairs repel each other and will therefore adopt the geometry that places electron pairs as far apart from each other as possible. And this theory is really simplistic and doesn't really account for the subtleties of orbital interactions that influence molecular shapes. However, the VSEPR counting procedure accurately predicts the three-dimensional structures of large number of compounds. So we're going to be using balloons to illustrate this theory. And we're going to dive into some examples of the various geometries and compounds that will help illustrate this model. So first up, we have a molecule with two electron pairs. So this here. This is going to be 180 degrees, which would make it a linear molecule. And an example of this would be CO2 or carbon dioxide. So next up, we have a molecule with three electron domains, 120 degree geometry, which gives it a trigonal planar shape. And an example of this would be BF3 or boron trifluoride. All right, so after this, we have a molecule with four electron pairs, 109.5 degrees and a tetrahedral shape. So an example of this would be carbon tetrafluoride, which would be illustrated by this. Next up, we have another molecule with five electron domains, 120 and 90 degrees, and a trigonal bipyramidal shape. So an example of this would be PF5 or phosphorus pentafluoride. So our last example would be pretty much putting these two together with six electron domains, 90 degrees, in an octahedral shape. So an example of this would be sulfur hexafluoride, which pretty much wraps up the examples that we're going to be using today. So I hope you found this video to be somewhat informative and hopefully covered everything. And I will catch you in the next one. Thank you.